Right now, as you watch this video, an invisible force is protecting every living thing on Earth. It deflects deadly radiation, it shields our atmosphere, it keeps our planet alive. This force is called Earth's magnetic field. You cannot see it, you cannot feel it, but without it, life on Earth would not exist. And recently, scientists noticed something disturbing. In one region of the planet, this shield is getting weaker, much weaker. Satellites passing through this area are malfunctioning, electronics are shutting down, radiation levels are rising. NASA calls this region the South Atlantic Anomaly. It is not science fiction, it is happening right now. And it raises a terrifying question. What happens if Earth's magnetic shield fails? Is this a temporary fluctuation or a warning sign of something far bigger? To understand the danger, we must first understand what this invisible shield really is and how it protects us every second. What Earth's magnetic field really does. Earth's magnetic field is generated deep below your feet, nearly 3,000 kilometers underground. At Earth's core, molten iron is constantly moving. That motion creates electric currents, and those currents generate a massive magnetic field that surrounds the planet. A planet-sized shield. This magnetic field stretches far into space. It forms a protective bubble called the magnetosphere. When charged particles from the sun slam toward Earth, the magnetic field deflects them. Without this shield, solar radiation would strip the atmosphere. DNA-damaging particles would reach the surface. Life would struggle to survive. Mars is a perfect example. It lost most of its magnetic field long ago. Today, Mars is cold, dry, and nearly airless. Earth avoided that fate because its core kept moving. Why compasses work? A simple compass needle aligns with Earth's magnetic field. That same invisible force guides birds, whales, and sea turtles. Life has evolved to depend on it. The field is not static. Here's the part most people don't realize. Earth's magnetic field is not stable. It shifts. It weakens and strengthens over time, sometimes dramatically. Geological records show that Earth's magnetic poles have flipped many times in the past. North became south. South became north. Life survived, but modern civilization has never experienced such an event. Enter the South Atlantic Anomaly. In a large region stretching from South America to Southern Africa, the magnetic field is significantly weaker. This allows more radiation to penetrate closer to Earth. Satellites passing through this zone often experience glitches. Astronauts avoid it when possible. NASA monitors it constantly because this region is growing and drifting. The big question, is this just a localized weakness or the early stage of a larger magnetic shift? In the next part, we'll explore what scientists are seeing, why this anomaly is expanding, and what it might be telling us about Earth's core. The South Atlantic Anomaly, what NASA is seeing right now. From space, Earth's magnetic field does not look smooth. It has dents, and the largest dent of all is located over the Atlantic Ocean. Scientists call it the South Atlantic Anomaly, a weak spot in Earth's shield. In this region, Earth's magnetic field is significantly weaker than the global average. This means the protective shield that normally deflects radiation is thinner here. As a result, high-energy particles from space can penetrate closer to Earth. Why satellites care? For satellites, this is a serious problem. As they pass through the anomaly, electronics can malfunction, sensors can be damaged, data can be corrupted. Some satellites automatically shut down sensitive instruments when crossing this zone. Even the International Space Station adjusts operations. Astronauts receive slightly higher radiation doses when flying through this region. What NASA has observed. Using satellite missions and long-term data, NASA has tracked the anomaly closely. Here's what scientists know. The anomaly is expanding. It is drifting westward. In some areas, it is splitting into two lobes. That last point surprised researchers. A single weak zone becoming more complex suggests changes deep inside Earth. The cause lies far below. The South Atlantic Anomaly is not caused by anything in space. It originates deep within Earth's interior. Far beneath the crust, liquid iron flows in Earth's outer core. That flow is not uniform. In some regions, it weakens the magnetic field above. One key factor is a massive structure in Earth's mantle beneath Africa. This structure alters how heat flows from the core. That, in turn, affects magnetic field generation. Is this normal? Here's the critical point. Earth's magnetic field has weakened and shifted before. Geological evidence shows anomalies like this have appeared in the past. So the South Atlantic Anomaly is not completely unprecedented, but its rate of change is what scientists are watching closely. Not a doomsday signal yet. NASA scientists are careful. They do not claim this anomaly means the magnetic field is about to collapse, but they also do not ignore it. It is a signal, a clue that Earth's core dynamics are changing. Why this matters now? In the past, a weakening magnetic field would have gone unnoticed. Today, our civilization depends on satellites, navigation, communication, weather forecasting, power grids. Even small changes can have large consequences. In the next part, we'll explore the big fear many people associate with this anomaly, magnetic pole reversal, what it really is, and whether we should be worried. Part 3. Are Earth's magnetic poles about to flip? Whenever people hear that Earth's magnetic field is weakening, one fear appears immediately: a magnetic pole reversal. The idea sounds terrifying. North becomes south, compasses spin, civilization collapses. But the real science is very different from the myth. What is a magnetic pole reversal? Earth's magnetic poles are not fixed. Over geological time, they have flipped many times. In fact, this has happened hundreds of times in Earth's history. During a reversal, magnetic north and south slowly weaken. The field becomes chaotic. New poles eventually reform. This process takes thousands of years, not days, not months, not suddenly. Evidence written in stone. Scientists know this because rocks record magnetism. When lava cools, iron-rich minerals align with Earth's magnetic field. As the rock solidifies, that direction is locked in. By studying ancient lava flows, scientists can reconstruct past magnetic reversals. The record is clear. Earth has flipped before. Life survived every time. The last flip. The most recent full reversal occurred about 780,000 years ago, long before cities, electricity, satellites. There is no evidence that it caused mass extinctions, no global catastrophe, just a slow transition. Is the South Atlantic Anomaly a sign of a flip? This is the key question. The South Atlantic Anomaly does resemble patterns seen during past magnetic changes, weak spots, fragmented field regions. But resemblance does not equal certainty. Scientists currently see no proof that a full reversal is imminent. The field is weakening, yes, but reversals are complex and unpredictable. What would a reversal actually do? If a reversal began today, compasses would become unreliable, aurora activity would increase, radiation exposure would rise slightly, but Earth would still have a magnetic field. It would not disappear. The magnetosphere would weaken, not vanish. The real risk is modern technology. Here's the critical difference between the past and today. Previous reversals happened to a planet without technology. Today, civilization depends on satellites, GPS, power grids, aviation systems. A weaker, unstable magnetic field could disrupt these systems, not destroy Earth, but challenge modern society. Scientists are watching the pace. The biggest concern is not if a reversal happens, but how fast changes occur. Rapid shifts could give us less time to adapt. That's why scientists track field strength, direction changes, regional anomalies, including the South Atlantic Anomaly. Separating fear from reality. Magnetic pole reversal is not an extinction event. It is a natural process, but it is also a reminder. Earth is dynamic, and the forces that protect us are not permanent. In the next part, we'll explore the most important question of all. What would happen to life, technology, and civilization if Earth's magnetic shield became significantly weaker? What happens if Earth's magnetic field weakens further? If Earth's magnetic field weakened significantly, the planet would not suddenly become uninhabitable. Life would not disappear overnight, but the world we rely on would begin to change, quietly at first, then noticeably. The sun becomes a bigger threat. The sun constantly releases high-energy charged particles. Most of the time, Earth's magnetic field deflects them. If that shield weakens, more radiation reaches near Earth's space. Solar storms become more disruptive. Atmospheric interactions intensify. Auroras would become more common and appear at lower latitudes. Beautiful to see, but a sign of increased energy reaching Earth. Satellites take the first hit. Satellites are the most vulnerable. Even today, when passing through the South Atlantic Anomaly, satellites experience glitches. With further weakening, electronics degrade faster. Sensors lose accuracy. Mission lifespans shorten. GPS signals could become unreliable. Weather forecasts would suffer. Communication delays would increase. Modern civilization would feel it quickly. Power grids under stress. On Earth's surface, the risk is more subtle. Strong solar storms can induce electric currents in long power lines. This has happened before. In 1989, a geomagnetic storm collapsed Quebec's power grid in under 2 minutes. A weaker magnetic field would increase this risk. Transformers could overheat. Large-scale blackouts would become more likely. Aviation and human exposure. At high altitudes, aircraft crews are already exposed to higher radiation levels. With a weaker field, polar flight routes face higher risk. Airlines reroute flights. Costs increase. Astronauts face even greater danger. Spacewalks would become more risky. Mission planning would change. What about life on Earth? Here's the reassuring part. Earth's atmosphere still provides significant protection. Life on the surface would not be immediately threatened. Plants, animals, and humans have survived weaker magnetic periods before, but long-term exposure changes are still being studied, especially for DNA damage rates, mutation frequency, and ecosystem sensitivity. The real vulnerability is us. The biggest impact is not biological, it's technological. Our civilization was built during a period of strong magnetic protection. We assumed stability, but Earth does not promise it. Adaptation not panic. Scientists are not helpless. Satellites can be hardened. Power grids can be redesigned. Early warning systems can reduce damage, but adaptation requires awareness and preparation. A planet that is still alive. A weakening magnetic field is not a sign that Earth is dying. It is a sign that Earth is active, dynamic, alive. In the final part, we'll step back and ask the most important question: is Earth's magnetic field failing or simply changing as it always has? Is this a crisis or a natural cycle? So after everything we've seen, the weakening magnetic field, the expanding anomaly, the growing concern, we return to the most important question: is Earth's magnetic field failing? Or is this simply the planet doing what it has always done? Earth has changed before. Earth is more than 4 billion years old. During that time, its magnetic field has weakened, shifted, and reversed many times, long before humans existed, long before cities, satellites, or electricity. Life survived every one of those changes, not because Earth was gentle, but because Earth adapts. What makes this moment feel different? What's different today is not the planet, it's us. We have built a civilization that depends on fragile systems: satellites orbiting Earth, power grids spanning continents, navigation signals guiding aircraft and ships. A weaker magnetic field doesn't threaten life itself, it threatens how we live. Science without fear. This is why scientists speak carefully. They don't use words like collapse or doomsday. They talk about probability, trends, uncertainty. Right now, there is no evidence that Earth's magnetic field is about to disappear, no proof that a sudden pole flip is imminent. But there is evidence that the field is changing, and that matters. Watching the planet in real time. For the first time in history, humanity is watching Earth from space. Satellites map the magnetic field continuously. Data flows in real time. Tiny changes are detected that would have gone unnoticed in the past. This doesn't give us control, but it gives us time. A planet that protects itself. Earth still has a thick atmosphere, a functioning magnetic field, and a dynamic core generating protection. The shield is weaker in places, but it is still there, still working, still defending life. The real lesson. This story is not about fear, it's about humility. Earth is not static. The forces that protect us are powerful, but not permanent. Understanding them is how we survive. Ignoring them is how we fall behind. The future is not written. Earth's magnetic field may weaken further. It may stabilize. It may reverse thousands of years from now. No one knows for certain. But one thing is clear: humanity is no longer blind to the planet beneath its feet and the forces above its head. The final thought. Earth has always changed. Life has always adapted. The question is no longer whether the planet can survive change. The question is whether we can adapt with it.